Welcome to another Synthium Live Hack. Just give me a second to mute my sound on this other playback video. There we go, and I'll pull up the chat. Let's pop the chat out so it's easy for me. All right. We got our music pumping. Turn that down a little bit. All right. Welcome, everyone. This is Live Hack number 50. Sorry, I had to do something special for number 50. So you can have my punches into the camera. Hey, Nomad. Thanks for joining us. Yeah, I can't believe we made it this far. Episode 50. It's crazy. It's quite a few episodes. Tonight is brought to you by Okanagan apple cider, orchard peach flavor. We'll see how it goes. Never had it before, so we're gonna try it out. Yeah, not bad. It's like a peach juice with a little bit of spice to it. Sorry, it's not a drink that probably is prevalent. Let's say it's probably not very. I'm at a loss for words for it, but like it's not very sourceable, maybe is the word I'm looking for other people around the world. I don't think they sell this Okanagan stuff beyond Canada, and if they do, it's probably just like into the lower United States. So sorry that you can't enjoy the same flavor of Okanagan's best here. The Okanagan Valley, if you're not familiar, is an area in southern British Columbia, which is the province over from Alberta, that has, I don't know what you would call it. It's just like a really maybe arid environment with lots of, I guess arid is not the right word because arid's like a desert. It's more like kind of rainforesty, let's say. But it's got a few desert elements, but it does get lots of moisture too. So it's a very weird place where fruit grows very, very rapidly. So my parents actually live in the Okanagan area, and I visit them every now and again in the summer, and it's quite a nice place, great place for vacationing. If you ever look up Okanagan Lake or Kalmalka Lake online, that's where we go usually. Very nice lakes that are, warm for Canadian standards. Maybe not that warm for everyone else, but they're really great. Okay, enough about me. Let's talk about this live hack. All right. This one is going to be a different kind of live hack, and it incorporates some of my other hobbies, which is skateboarding. So a friend of mine, Zach, shout out to Zach, Crate the Great on Instagram. He said he thought of, hey, we want to test different types of grip tape, which is this stuff right here on the top of the sandpapery stuff on the top of the skateboard. I want to test different brands because there's so many brands out there and they all claim to be the best. How could we have an imperial method of, I think imperial is the right word, method of actually testing like whether the grip tape is good or it's going to last, like some sort of let's say measurable method to see how grip tape does compared one to another. And so we thought, hey, my friend Zach jokes, he's like, hey, why don't we build a robot that could do it? And when people say that kind of thing, that kind of like it puts like a challenge in my mind, and I'm like, yeah, we could probably do that. He was only kidding, but I'm like, you know what? Yes, we could probably do that. So let's make a robot that can test grip tape. And so that's where the idea for this live hack came from. So I've never done anything like this. It's going to be kind of in a partly industrial kind of project, I guess. Something that can just repeatedly do something over and over. And so there's going to be definitely a learning curve. I've never done something to this extent, I guess, and industrialized. And so we're going to see where it goes. I'll probably make a lot of mistakes along the way, but hopefully we come out with a successful robot by the end. So let's introduce you to some of the parts that I have here. This is one of the main parts I 3D printed already. This is the replica foot that will be dragging along the grip tape. So this is simulating somebody doing an ollie, which is a common trick skateboarders do to lift the skateboard off the ground. And so what happens, I kind of show you with this other view here. So we'll put the skateboard deck there. Get this out of the way. And so usually the front foot for an ollie drags up the board like this. And that's where you get contact with the grip tape from the shoe, simulated shoe here, to the grip. And so we want to test out like how long this grip is gonna stay grippy, if you will. I know, not technical terms, but that's the terms we'll use. And so what I had done is actually used TPU material here. Oh, sorry. I'll get it into view here. Sorry. Backwards orientation. So yeah, this white piece is the TPU, which is like it's kind of rubbery substance. And you can see I didn't make it 100% thick. I just made it so that once we get to this point right here of wear, then we know to replace this. And so I'm not too sure how long it's going to take to wear this down. And we'll see, this will likely wear down way faster than the grip tape will. So we'll see how often we have to replace this. And this shoe is just your common PLA. I modeled this after a mannequin's foot. And then added some bearings in here so that this can be pivoted wherever we need it to go. Yeah, what else can I say about this? Yeah, it actually uses skateboard bearings, funny enough. Oh, sorry, you can't really see that. There we go. One there and one on the other side. And yeah, this probably, I think this took over 30 hours to print. It, yeah, did alright. I designed it in Tinkercad because that's what I've been using these days. And I designed it to be replaceable, so see if I can get in there. You can see in there that the nuts are actually trapped in the plastic there, and they're a jam nut. So they should stay in there while I can take off these actually are skate hardware, skateboard hardware that usually goes in right in these holes here to hold the trucks on the skateboard. I used it for this, so all kinds of skate hardware involved in this project. And these clamps here, I think they're actually for canopy or something for the back of a truck, I believe. But I found them at Princess Auto, just a regular kind of a surplus supply store. They sell all kinds of stuff, mainly tools from China. And I'm using those to clamp down on the board to hold our board where we need it to be. But I don't have the main chassis, I guess, for this robot done yet. So I'm going to be cutting that out of. Oh, so hopefully that's not too loud. Diamond plate. This stuff is like I think this is an old running board that's for a truck or something. I don't remember where I got it, but somebody gave it to me, I think, and it's a good source of aluminum. So what I'm going to do is use a jigsaw to cut a piece off this running board so we can start mounting the majority of our parts to it. When we get to that point, I might mute the volume or something, because definitely going to be loud cutting that aluminum. And so I'll show you guys over here on this other desk. Well, I should say that I'll be trying to use the Rock Pi X for this project, so that's why I have that out here. I also have an H bridge, which is going to be driving. Excuse me. I'm going to probably use, what do you call that? Double up on the. Sorry, I should have transferred the video there to show you guys this. I'm going to pair the channels, so instead of having them be 2 amps a piece, it's going to be 4 amps total, because I do have a pretty large motor that'll be controlling. So switch over to that in a second here. Here we go. So this is the motor we'll be using. So I believe it's a 12 volt windshield wiper motor, I'm pretty sure. Yeah, I don't think it's a window motor, I think, or like your regular up-down for your power windows. I believe this is actually for your windshield wipers. I think that's what this thing is, and it goes round and round. And so we have a bit of hardware here for mounting the motor. I will have to trim these down, they're too long, but they do fit really well. They're the right size. And we also have an Arduino here, Arduino Nano, that will run from the Rock Pi over USB to ARC, and this will be controlling the H bridge. So we might kind of try to combine these somehow and to mount them together, make things easy. But that's all we'll be using the Arduino for, is to control this motor. And also we'll have an ADC line connected to the ground of the motor to see if we can measure current. So that's going to be important for this project. We'll be measuring, how grippy the grip tape is over a period of time, and so we can actually measure that with the current of the motor. So if the motor starts, going around and around, and it's easier for the shoe to slide along the grip tape, we can tell that with the amount of current that this motor draws. So usually you do a current sensing resistor. That's the common way to do it. But DJ actually figured out that you can just tap off the ground and sometimes get a little bit of voltage that comes off the ground, which tells you how much current draw there is. A little bit of voltage difference. So we'll try that. We'll try that first, and then if we don't get that much reading, let's say, that many numbers, we'll switch over to using a power resistor. So looking at this motor, I'm not sure what this header is for. It does have some numbers on it and stuff. I don't know if you can read that. I'll bring this in a little closer. Come over here. Alright, so it says 53B, A, E, 31B, and 53, so that doesn't help us at all. I thought, hey, maybe this thing has like some sort of encoder or something on it. It does have a couple of wires that were snipped off here at the back. And if you guys have any experience with wiper motors, and maybe you'll be able to tell me if there's anything useful, I guess, connected to this connector here. I haven't really researched it much. I could look online and do a quick Google search, but hey, right now I'm hacking, and so I'm gonna be using my hands instead of my eyes and fingers to type out type out on the keyboard what I need. So if you guys want to do that, definitely do that. It would be much appreciated. And then we have some wires here to connect up to the motor here, because we got little tiny connections here. You need to make those a little longer to get to the H-bridge. So to put this all into perspective, let me show you everything for a quick second here. So we'll have a motor which will be mounted to the diamond plate. Let me move the microphone over here. The motor will be connected to the diamond plate, and we'll be turning this thing around, which this guy will be connected to. So we have to kind of measure out and see where exactly or how far down this can go. And we also don't want the heel of this item to hit anything. So we'll have to keep that in mind and have a spacer here probably. And then this shoe will be connecting with the skateboard. So we will need the skateboard attached to these clamps, and these clamps will also hook up to whatever you figure out for this guy. That's the idea. All right. Oh yes, and we will be controlling with those electronics that I just mentioned. All right, so first things first, let's do a little bit of soldering. Just got some stuff to solder, and then I'll have some bolts to trim down. Actually, let me check something out. I'll be right back. I was looking for a crimp tool. So I don't know if you guys are familiar with crimp tools. They squeeze these type of connectors. I think they call them butt end connectors, or spade connectors, I think. Anyways, they not only do they crimp these type of connectors, they also have a piece of them, or an area on them, that accepts screws such as this. You can thread right into the tool, but the cool thing is that you can actually shear bolts with it. You screw these in, and then you squeeze it really hard, and you can cut off what you need off of bolts, or machine screws. But we don't have one, so we are going to be forced to use the Dremel tool to trim those down. Alright, so let's light up the soldering iron, get that hot, get our safety glasses on. Strip those wires. Oh, if you have any questions or ideas, definitely jump in the chat and let me know. Grab some heat shrink as well. You don't want those wires touching the chassis or anything. Oh yeah, these are handy. I think you can get these at Princess Auto as well. There's a company called Circuit Test. Yeah, there it is. That produces these in North America. They're pretty handy. Just comes in, it's just a heat shrink. It comes in a variety of sizes and colors. Nice. Looks like my wife has joined us. Welcome, Martha. We're about to do some soldering. Dremels are definitely a great tool to have, but they're very loud. See if I can pop this guy off of there. Nope. You know what? I'm gonna grab a big pair of snips to chop that right off of there so I don't take off any excess wire that I could use. I don't know where the large snips are at, so I'm going to use these large needle nose pliers that have an interesting section on them that can cut some large things nicely. I don't even know what you call that section, but the snip section, let's call it. Tougher than it looks. I guess the plastic is protecting the metal underneath. There we go. We got it. Beauty. All right. So that's not very much wire left there, so we're gonna have to get in there and only take back a little tiny bit of insulation. There we go. Looks like the wires are pre-tinned. They've been soldered before, so that makes our lives a little easier. I think what I'm gonna do is just make a couple hooks on each side. Make it easy to solder that way. And bend these into a U shape. Now, having yellow and white wires here isn't very helpful. I don't know which is ground and which is positive and which is negative, but it's not going to really matter much. We're only going to be spinning in one direction, so. If it's the wrong direction, then we just reverse the wires connecting to the H-bridge and then we're good to go. So I'm going to tin the other side here of these wires, put them into a U shape, and then solder them up. Give me 1 second, I'm going to grab some tape. Electrical tape makes everything so much easier. Alright, well, what's everyone up to tonight? Or this weekend? Jump in the chat. Oh, yes. Yes, I do have a new camera. I bought it from Amazon because it had a lens on it that you can actually adjust, and so if you want to get in real close, you can adjust it and get a nice clear picture on some zoomed in areas. But it is nice that it does have a little bit more color to it. Makes things pop a little better. And welcome Bro Rad, welcome. Yeah, let me know if the music is drowning out my voice. I do have it up pretty high today. We have to because it's the 50th anniversary, right? Okay, let's make these into little hooks and solder them on. Alright, what do we do here? White to black? I don't know, this is so weird. Motor color codes are usually common red and black, but the automotive industry doesn't have any standards really when it comes to wire colors. They use some really weird ones, especially when it comes to audio. I guess they do have yellow is 12 volts and black is sometimes ground, but they also have some weird some weird colors like mauve and indigo and brown with red stripes, like all kinds of weird stuff. Alright, so see if I can bring this in closer and have it still focus pretty well. Do a little adjusting here. There we go. Use my pliers here to hold this into position. Alright, here we go. So, how's everyone holding up during this COVID season? We've had definitely our fair share of interesting situations this summer and this fall. There has been a case at my daughter's school and at my son's school actually. Probably multiple cases. And every time something like that happens, you gotta be real careful. Alright, I think we're good there. I'll have to trim down that a little bit so the heat shrink can get over it. We'll solder the next one. And then we'll worry about trimming everything up. Yeah, I think I've had to get the COVID test done 3 times now, I think. Yeah. Luckily, actually I think it was 2 times, but luckily for me I never had to do the test where it goes up your nose. I only have had the one that goes to the back of the throat, and that one's pretty easy to get done. Alright. Darn pliers aren't holding it where I want it to be. There we go. A little holding trick for you when you're having to solder things in an awkward position with items that are cylindrical. You can use your pliers to to hold it above the surface and hold in such a way that you can actually get a good angle on what you're soldering. Okay, looks good. Let's start trimming some of the sharp bits away. If you're curious to what we're listening to, it's what we've been listening to for the past few live hacks. It's a copyright-free playlist that I've made off Apple Music. It incorporates some songs from No Copyright Sounds, if you're familiar with that, from YouTube, and a few others, some artists that I've found over the years that I enjoy that produce copyright-free music or royalty-free music. There's also some bands that have been on a website called 99 Lives. I think DJ introduced me to that one. That stuff's more like the dubstep kind of stuff. Okay, so no more sharp edges there. I think my heat shrink is actually probably too small. I might have to go with a larger size. Yeah. Let's get the circuit test container back out here. Let's get the next size up. Red and white, I guess. Oh, let's just use yellow and white. The wire colors that it was originally. Alright. So I've tried this motor actually a few times in the past. It draws about 4 amps. And that's, I think, at its most strenuous under a ton of load. And so this guy right here, if we pair up his channels, we'll be able to deliver 4 amps. We'll see how it goes. I'm pretty sure with the L298, these motor drivers, if you cause them to overheat too much, they just go into thermal shutdown. They don't actually break or anything, so that's excellent. Kind of a safety feature. Works in our favor. Right here I'm using a hot air rework station as a heat gun. Shrinks that heat shrink real quick. Alright, there we go. Pull this back a little bit. So one thing I hadn't thought of is that I need a high current 12 volt power supply. I'm sure I have something around here, and I could always use, a classic Xbox 360 power supply, as I'm quite familiar with those. Some of them deliver only 12 amps, but they can go up to 16 amps. Way more than we need, so that would be handy if we had that. But I don't have any of those here at work. I only have them at home. You can also use a computer ATX power supply as well. Yes, sorry I missed your question there, but yes, Roborad, this is a wiper motor. Good eye. Oh, nice. Are you using a wiper motor on your Cylon robot? And yes, I think I'm in agreeance. I believe that Christmas is likely to be canceled this year for sure. Looks like things are not going so well in terms of numbers. I don't know how other countries are doing, but I'm guessing Ontario and Alberta are not doing that great here in Canada. Numbers of 1,700 new cases a day it's getting crazy. Okay. You know what? I can probably hit this with the benchtop power supply just to give it a quick test. It has been a little while since I've used it last, so I think it'd probably be good to test this thing out. And the wires I attach to this are actually high current silicon wires. These are used in the RC industry, usually for power management with LiPo batteries. They deliver a ton of current because they got a really low gauge of wire. I believe these are 16 gauge. Yes, 16 gauge. I don't know if you can see that. Maybe I pull this in and you can see it better. If I there we go. 16 AWG, that means 16 gauge wire. Now don't ask me what AWG means because I don't remember. I think it's American Wire Gauge Standard, I believe. Don't quote me on that one though. Borrow DJ's little adapter here. This thing's pretty handy. So I can plug my benchtop power supply into, because it's got a male barrel plug, and then we'll attach black to black, red to red. We'll see how this goes. I think I only have it set to about 5 volts, I believe, on the supply, so I may have to turn it up a little bit. Here, maybe let me switch the views here for a second. If I can find my mouse, there it is. So here's the benchtop power supply there in the corner. Yeah, there we go. So with 5 volts applied, this motor is spinning. That's kind of good news. We might be able to use just 5 volts. Let's see how fast it goes. It's drawing right now 2.9 amps. So it's definitely going to make this guy pretty hot. Alright, let's crank the voltage. Soldier boy. This thing is standard 12 volts. Oh man, the current is going way up. We're at 4.3 amps right now. Alright, that's 12 volts. Now I don't want to put my hand near that thing. Well, maybe I will. But it's super tough. You don't want to get your finger caught in between those things, because this thing will have no mercy and wreck your hand. So after working for a little bit of time here, it's at 3.5 amps. So it probably takes a little bit of time to warm up, and then the current draw goes down. So this is going to have this amount of weight on it. This shoe-ish thing. So that will actually cause the motor to draw a little bit more current as well. I'm guessing an extra, probably like 500 milliamps or so. But it seems to be dropping even further. Yeah, definitely. This motor could definitely pull heavy robots through the mud and grass. So these motors you can actually get for a pretty decent price at, I believe this is from Princess Auto as well. Yes, it has the classic Princess Auto sticker on it. They're usually, I think, around, correct me if I'm wrong, Roborad, around like $15, $20 for these motors. You can also get the motors at are power window motors, 12-volt power window motors that are pretty torquey as well. You use those for larger scale robots. Surprisingly, this motor is now running down to 2.8 amps. As it warms up, it draws way less. So we could actually I was thinking about using a lower voltage this whole time with this motor. I guess we don't need it to go this fast. We can PWM the speed down as well. So right now I'm guessing in the like 7 or 8 volt range is okay, but I think we will end up using 5 volts because we have a 5 volt 20 amp supply that will be easy to use. So at 5 volts we're drawing 2 amps. So we could use a single channel on one of these L298H bridges, because it's one of the channels is rated for 2 amps, but it'll probably get pretty hot and go into thermal shutdown. So if we pair up the channels, we should be able to make it happen. You know, I've never tried pairing the channels on these things. I'm guessing we're going to have to be very aware of the polarity of both the paired channels, because you don't want to reverse the polarity of one channel to the other, because I'm guessing bad things will happen. So I'll have to be cognizant of that when we do that. All rad. Sounds like RoboRad has all the good motors, all the heavy duty motors. This is the only one I have from my collection. But if I build larger scale robots, I definitely want to get some more. Alright, so let's stop that. It actually went up. It's a 2.5 amps, 5 volts. So we'll have to be aware of that. At 5 volts, the current doesn't go down, it might start going up. Alright, so since we have that here, let's just plug these in. And so if I pull this camera in close, I don't know if you can read that very well. We have motor A, VMS, I guess it says. I thought it said VN, but ground. 5 volts. 5 volts actually comes off the regulator here. It's a 5 volt output, so we don't need that. And then motor B. So we're going to have to bridge the motor A and B connections. And maybe I won't bridge them yet. Maybe I'll do some testing first to see. I want to see the polarity and see which is which. So I'm not going to reverse when I have them bridged. I don't want to reverse one of them. But for now, I was going to say we're going to attach the motor, but not really. Oh yeah, I guess you know what we could do. I was just thinking about paralleling the connections off of the channels, but what we could do is bridge one to another with the bridge wire and then go here to here for the motor connections. You know what, I've never actually done this, so let's go online. Let's go see what other people do here. Join me on the computer for a moment.
Got quite the party going on here.
Oh yeah.
You're spinning really fast.
This guy.
Is it going quick?
At 12 volts goes pretty quick, yeah.
Really, eh? Is that a 12 volt motor, right?
It is, yeah. It can actually work down to 5 though. That's the nice thing.
5 volts. How many amps did it draw? 5 volts though.
2.5.
And at 12 volts?
2.1. Or it actually drew like 3.8 at the beginning, but then as it warmed up, it got a little better. Have you ever bridged the channels on an H bridge before to make one more powerful H bridge?
You can't do that, can you?
Yeah, you can.
Because are you going to generate the same amount of heat?
No, it's like it gets shared between both H bridges, so you get the thermal shutdown doesn't happen as quick.
So you hook up your NA on one to NA on the other?
That's what I'm trying to figure out. Do you go in series or do you parallel them?
Well, you wouldn't go in series. I would think you would parallel them. The series would put all the load on the first one.
I was just thinking like you put one wire between.
Yeah.
And then put your motor across like that.
Parallel, yeah.
No, parallel would be like both.
In one and two would get the same.
Would have like the wires coming from and meeting out here. So I'm just looking it up. Parallel on H bridge.
Yeah, right there. That's what I thought it would be like.
This,
yeah, it's in parallel.
No, this is a BLDC. It's a 3-phase motor. No, that's not it. I think it's a parallel dual H bridge, I think, is what I'm looking for. I know it can be done. I've heard of it being done before.
I think you're crazy, but maybe. I could see if in parallel it would make sense. In series it would not make sense. Right? Because think of it as just 2 transistors. Think of it that way, right? If you're going to try to have 2 transistors doing the same, and you have a motor.
They're sharing the load, is what's happening.
But not if they're 2 in series.
Well, it depends how you connect the motor, right? So if you have one side of the coil on each transistor,
you have an NPN and a PNP.
Yeah, it's.
But you don't.
So it's still being shared across 2 H bridges.
Okay, so. Okay, so I can see what you could be saying though. So when you make one H bridge go forward, the other one has to be going reverse.
Yep.
Oh. Yeah. Okay, you can do that. You shouldn't even have to look it up. Just do it. It'll work. It'll work. Why won't it?
Oh, look at this. Somebody says it's not recommended.
You know why it's not recommended? Because when you turn your H bridge or your motor switches directions.
Yeah, it's going to be tricky to do with the signals, right? You're going to have to be careful.
Well, you're not going to have to. It's not going to be careful because you do it all in here. So your input coming from the EZB, whatever goes into.
The inputs are here. Yeah.
So whatever goes in one, will have to go into in.
Oh yeah, I guess I could parallel the signals as well.
Yeah, going in, you parallel. You parallel the signals, but you reverse them. So in 1 goes to in 4, in 2 goes to in 3.
Yeah.
So therefore, your output would be reversed on each channel of your H bridge.
Somebody says that's what I've been doing in my robot. They burn out after several days. Eventually, switch to a better IC.
Well, try it. See if it works. Hook it up and see what happens. Eventually, it'll work.
Yeah, some people say it works and it's running for them.
Some people don't know how to hook it up, though, right? That guy who says it only works for a couple of days probably has no idea what he's talking about.
Hard to say. It is Reddit, so.
Yeah, and most people don't know.
Because I think I read it in the data sheet that it is possible.
what you're waiting for. Just do it. Do it.
I'm like, oh, perfect. I found a diagram. And then it was a 404.
You don't need a diagram. I know what to do.
I just want to have something to look off of.
You don't like my hooking the ground up? ABC to the ground? Let's do it.
Seems like everyone who's done this before it's been a long time since it's happened.
Because you can get pretty decent voltage or H bridges. More juice.
Yeah, you can get better H bridges these days, that's for sure. All right. Yeah, it looks like somebody says they actually paralleled the motor wires. It says one motor output to channels 1 and 4, and the other to 2 and 3.
Yeah. Sounds like something I just said. Is there an echo in the room?
No, that you were talking about the input. They were talking about the output. These guys.
Oh, the output would be the same.
Yeah, but what you're saying specifically the input.
Oh gosh. Potatoes.
I just wish somebody had posted some sort of wiring diagram for this. Well, we're just gonna have to try it, as DJ said. Let her buck. That's the way it goes. Sometimes.
Ride her bareback.
Yeah, just give her.
Ride bareback. It's not sexual. It means riding a horse without saddle. Why do you have to turn everything into sex?
Because that term has been
It has never meant anything other than riding a horse.
No, you know it's meant other things. That's the why you brought it up.
I do not know that. Who keeps updating ARC every day? Every time I load my computer, I have to update ARC.
Yep. All right, so let's do it. Oh wow, there's been all kinds of chat happening and I've gotten behind. Give me a second here, guys.
Look at that.
Oh, neat.
Doesn't like when I turn it.
Is that the real, oh yeah, Intel RealSense camera?
Yeah, I can
Neat.
see when I turn it. I just sit here. How much drift do I get? Oh, I got tons of drift. Look at it moving around. lost its tracking. Oh, look, it just jumped up to here.
Not absolute positioning, I guess.
No, it's just drift.
Alright, so what I'm going to do here, these wires are long enough that I'm going to cut a portion off, and we're going to make these parallel.
There you are, Jeremy. Oh, bubbly.
Nice. And upside down. There we go. Here, I'll try to move that up a little bit for you. Well, that wasn't exactly in the middle. Not bad.
Cable's pretty thick.
Well, turns out I didn't cut off enough, so grab some more.
It's slowly moving up. Just sitting there. It's
Weird.
moving. I'd like to say it's weird, but it's not. That's the problem with the issue that we're facing.
Okay, we'll solder that, and then we'll heat shrink it up, and then we'll attach it to the motor driver.
Martha's on there.
Yeah, she was there for a little while, I think.
Oh.
I'll grab my trusty backing for breadboards. I never use breadboards anymore, but I do use this backing quite often when I'm soldering it, so I don't melt the mat.
Man, you still haven't set up push that button, eh?
Push what button?
The one that sets you for low latency. Your video is like 2 minutes behind.
Oh,
That low latency button when you set up your stream.
I forgot all about that actually.
Yeah. So what everyone's seeing and commenting on is from 2 minutes ago.
Gotcha.
You're still soldering it now. Still soldering. Still soldering. Almost done.
Well, it's not 2 minutes. It's probably like 30 seconds behind.
Oh wait, you're way back. Look, you're still soldering and you're talking to me right now. Oh, you just put your thing back. Yeah, maybe about a minute. Chip tunes?
Yeah. Royalty-free chip tunes.
Is there such a thing as royalty chip tunes?
Yeah.
Is it?
It's called Anything by Nintendo.
Really? If you record it, they'll know about it?
Oh yeah.
No way. Crazy.
I mean, I don't know how long of a recording it has to be, but yeah, Nintendo comes after anybody for anything. Not a very happy company.
Yeah, they are 100% a licensing company.
Yeah.
They're not a video game company. Never have been.
No.
Since Donkey Kong.
They just have all these characters they would license.
And they don't make the characters.
Nope. Couple more pieces of heat shrink here. There.
Crashed.
There's a bunch of wire bits on here. You can get rid of those. Don't want the H-bridge shorting out. Okay, so we'll bridge these connections. 2 and 3, 1 and 4. Put it this way so you guys can see what I'm doing here. Kind of. Here. Pull this back a little. Might hit these with a little bit of solder so they're easy to push in there. That's better. Grab grab the handy needle nose pliers to get it right in there.
You're a handy needle nose plier.
There we go. That's true.
Go to your motor, so you connected your second set of eyes. You good? Yes, that's correct.
So we'll have to upload the EasyB firmware onto this Arduino. Also got
Is
a...
there an Arduino on that board?
No. I have an extra one over here. Alright, there we go. I'll trim this down a little bit, it's a little bit long. I guess that's the problem when you're using 16 gauge wire and trying to fit it into these terminal blocks. It gets tight.
Is it the juice wire?
There we go. The go juice. The voltage wires.
I didn't think you'd need to do it the way you're doing it, but I guess you could do it that way, right? I thought you would just hook up your the positive from one to the negative of the other.
That's not how they said to do it online.
Yeah. This will. In your mind, if you hook up two transistors together, what would happen?
They would share the current.
Do they?
Yeah.
Has that ever been happened before?
Yeah, people are doing it.
No, like, have you seen just two transistors before and stuff like that?
Only in this application.
Yeah. Excited. I'm excited to see what happens.
All right. Clean off the bench a little bit. Get these little bits of solder and wires out of here. All right, where's that Arduino? Here it is.
Which one are you using?
Nano.
Alright.
Flip it upside down. Solder those headers on. Yeah, those part spins that we have here in the lab are from Home Depot. $1 each. Pretty handy stuff for organizing. So out of all the 50 hacks that I've done, let me know in the chat.
What's your favorite?
Which ones did you like? That Rock'em Sock'em life hack was definitely a beast of a... I guess I probably did like 10 live hack sessions on that project. So many failures, but I was glad to ultimately have some success at the end.
It was a success. I think of it as a success.
Mm-hmm. Well, you gotta have some failure on the road to success, right?
Oh yeah.
Okay, so let's hook this guy up to the laptop here, and we'll get the EasyB firmware on there. Make sure it works and everything. I got these random USB cables from my collection, so I'm not sure if they're good or not. Looks fine to me. Okay. Just give me a second here to load up Arduino. Arduino always seems to take a while to load up for some reason. It's supposed to be a pretty lightweight program. Nice. I think I'd already preloaded the code that I needed, so it's a beautiful day. Here we go. I'm going to select the Arduino Nano, and we also have to select the proper COM port. Just 12, let's see. Checking our device manager. Here's our device manager. Drop down the COM ports. There it is, COM 12. Yep, this is the one. Upload. You can't see there, but it's still compiling at the bottom. Uploading now. The LEDs are flashing, and it's done. Perfect. Okay, now we can load up Arc. I know if I forget, remind me. I have to change the baud rate on the connection skill. I always seem to forget that.
You have to?
Yep. Oh, there seems to be a new Arc released.
What version are you running now?
I think I had yesterday's version.
2 days ago.
12.2.01 maybe. Yeah, I have 12.01.
So many good fixes since then.
Oh wow. Okay, EasyB 1, 56, 57.6. Yep. And then we got to be on COM port 12.
Oh, right, because of
Connect.
Nano.
There we go. We are connected.
Nano has a FTDI or something, right? Or something.
Yeah. CH430 340.
Yeah, that's why you have to change the battery. You know, that stuff, it's micro.
Oh,
More than our
yeah, I guess.
They're
All
just
right.
USB devices.
Oh, yeah, true. Just hook up to the
The
COM
option's
port.
there, but it doesn't make a change.
All right, add a H-bridge skill here. Okay. So we're going to have to parallel our signals. I think I have some cables that do that. Give me a second. Male connectors. I need all female connectors. Alright, let's make some bridge jumpers. Party people, let's make some noise. Separate these two out actually. It's weird, I don't know how, but I keep on leaving my solder all over the place. I end up on the other workbench somehow. Darn it. Broke those in half. Oh well. Let's just place it this way. So these wires are going to go from one signal wire from they were doing nano and bridge across two signal wires on the H bridge. probably throw in some heat shrink just to be safe. We don't want to go bareback like DJ says.
Attaboy!
We're not going bareback. Oh, darn it. The heat shrink is not big enough to go over top of this connector, so we're just going to pop this connector right off here. Use a little dental pick. There we go. Alright, so let's heat shrink those guys and then we'll start testing. So really, we actually don't even need the H-bridge control to test this. We could just go plug this into ground and 5 volts on here. That would work too. But we do need some power applied here. So let me grab a few things. Yeah, my Astro Boy.
Yeah, right. You need to finish that.
Yeah, I do need to finish that project.
You mentioned that.
Double rad. Yeah, actually, the nice thing is that I was using a Atomic Pi at the time when I was creating Astro Boy, and that was just way too big of a board. So I'm going to move over to the Rock Pi X and use that, and that should bring the form factor down quite a bit. So I was scaling everything up to fit the Atomic Pi. Alright, before I plug in the signal wires, I'm going to put power to this and see if it actually... I think because it has this enable jumper over here, it will actually use the regulator on the board. Power the L298's logic gates. Okay, we're at 5 volts. We'll have to turn that up to 7 at least. turned up. And we'll use our little adapter here. Make sure there's nothing touching. Okay. Okay, there we go. We have all of our LEDs have lit up on this thing. Not sure why all the LEDs are. Maybe it's by default they're on, and then once you bring them low, they turn off, or bring them high, they turn off. I don't know. Okay, so let's hook this up. I'm going to go to D2 and D3. Actually, D3, D4. Okay. Let's switch over to arc. Bring our PWM lines up a little bit.
Your PWM hooked to it as well? Taking the PWM?
Oh yes, I didn't know. I didn't hook up the PWM. So I'd have to take those and bring them. Make another one of these actually, and bring that in high. I forgot about that.
I don't know if that does PWM, the Arduino.
No?
Well, yeah, it does. It has to. Of course it does. Right?
For sure.
We'll take a look at your debug and see if it says PWM supported. PWM duty cycle on digital parts.
Yep, perfect. We are supported. Now these, I actually have to bring these lines high at least because they are actually enable pins.
Yeah.
So, forgot about that with the L298.
Just hold them high and see if it moves. Once you bring your voltage down to like 5 volts, then turn it on.
Yeah.
That way you can ensure that the PWM. I don't know, but Arduino must have PWM.
They do, yeah.
Can't trust it.
So we're going to make ourselves one more of these. I'll be quick about it. Don't worry. You know, one thing I forgot, the common ground.
Oh my god, Jeremy, to explode.
Sorry guys, I'm neglecting the chat once again. I'll be back in a second. Just concentrate. 5. Okay. Okay, there we go. We got everything hooked up. I should grab yourself one. Okay, so we have our PWM hooked up. We got, let's see, I think it's, see if I, do we have all the cameras set up to see what I'm seeing? Everything except for the, I guess you can see arc kind of on this screen over here. I could bring that in a little closer. There we go. Okay, I think we are braking, not braking, but braking, stopping on the motor right now. So I just need to switch the logic around.
Oh no, your stomach switch LA.
Well, I can hear the motor whining a little bit. Let's get this last pin in there. Oh, I think maybe we had it right. We don't have enough juice because I forgot. We're only running at 5 volts, so our PWM is going to have to be cranked. There we go.
That should fill. Is that full juice?
No. Well, that's full 5 volts. So, sorry, 7 volts. Can you stop it with your finger?
Yeah.
Oh.
My finger again. Jeremy, little girly fingers. So with 7 volts. 7 volts is not very much for that motor.
With DJ, it's push my finger, not pull my finger. Yeah, I can crank the voltage up.
What's going on there? What God? Voltage. Wow.
There we go.
What is that?
So that's 10 volts.
Oh, you'll never stop that.
And this is, it's getting warm.
Can you keep your fingers on?
Nope.
Oh, that's warm, man.
Yeah.
My hands are cold, that's why.
Just put your hands on there. Woo!
Where's the gun? There it is. There.
Okay, so we've made it happen. Let's see what we're at. 40 degrees, 46 degrees Celsius.
The question is, switch directions quickly back and forth. Is it going to pop up?
Oh yeah, that's a good idea. I can smell it getting hot. Okay. Oh, it can handle it because it has those flyback diodes.
How can you not share your screen in that window?
I can.
but they wouldn't be able to see this. Well, I guess if I actually 1 second here.
Make a scene
Here,
where your screen is.
yeah, there we go. So desktop work area and me. There we go. Whew, that's how to hit it with my arm. Yeah.
Where's she at? 60, 67, 81. 81's the highest I got from it. 82.
That's hot. It'll probably go into thermal shutdown around 125 degrees, probably.
84. 86. 86.
The fan on my power supply is kicked in. It's drawing a few amps.
86.5. 87. She's climbing. You might have to put a fan on this.
Fans.
89.
We don't need no fans. Come on.
It is climbing non-stop. Oh, she's warm. You can cook something on that.
Oh yeah, for sure.
I'm surprised it's still going at 90 degrees.
Yeah, me too, actually. So usually with H bridges like the L298, if it gets too hot, it will enter thermal shutdown. It'll just stop spinning the motor. We'll see how it goes. We'll let go for a little while. The current has went down to 2.4 amps. Yeah, I don't think I can stop this with my finger. Nope. Definitely gonna cut my finger doing trying that.
Yeah, I probably will. I don't even think I want to try that.
Don't try it. Oh no. 4 amps. Nope. Oh, you did stall it. Wow. And it did not enter thermal shutdown when you stalled it. That's surprising, actually.
That is super surprising.
So I think our parallel channel
It's working.
thing is working. Yeah.
I'm impressed.
We've done it. Thank you, Internet and DJ.
Well, and that guy says it couldn't be done and it blows up.
Yeah, well, we're not running this for days like you said he was, so. Alright, well, I think this is good enough for me. Let's stop this for now. It's a good test. Right on. So, now we can enter the next phase of our project. Drilling and the mechanical phase. Boop, boop. And cutting. Yeah, so we're going to have to trim those bolts. We're going to have to cut a whole bunch of aluminum off of our diamond plate running board. Take these. No, I will need these still. Never mind. I'm going to shut down the solder iron. Okay, so that phase of the project is done. The control phase. We still have the SBC phase, which is single board computer. The Grippy X will be running this. I still have to upgrade ARC on the Grippy X and a few other things. Probably do that in my free time. Tonight I think we'll just go as far as getting everything mounted and that figured out. Glad we have this control system and the electronics figured out. That's cool. That's my specialty, I guess. Get the stuff that I know can be done easily first. But we actually did do a little bit of risking there. I didn't know exactly if that would work or not, but yay! It works. So this is the point where you'll probably want to turn down your speakers a little bit. I'll be using the Dremel tool. I'll be using, you know what, I might have to go to the back actually to use the jigsaw. I'm going to spray up a lot of metal and material. I just don't want to be covering the lab here. Probably not a good idea. Alright. So I'll switch the view here so you can see me back there using the Dremel tool. What I never did buy a pair of earmuffs. Probably would have been handy. Just measuring how much depth I'm going to need for these. So threads go to about here. So one more cut off. About that much. And then we'll use the tap and die set to rethread that, because it always makes a mess when you cut it with the Dremel. Alright, cover your ears. Here comes the Dremel.
How are people watching?
Do we have a hacksaw?
How come you're not using your camera? Yeah, there's a hex in the back.
Is there?
Yeah.
Oh, whoops. I forgot to transition. Sorry.
You're not using that camera there.
I guess I could use that camera there.
Yeah, they're close to you. Maybe,
Computer, yeah.
do you have an extension cable? No way, we don't have any of that.
Hey Pedro, thanks for joining us. You came in just in time to watch me Dremel. Well, I don't have something like that. I could do this. Oh, that's why. Whoops. Alright, there you can see us better. You missed all the good stuff, PTP. We dual or paralleled the channels on an H bridge for the first time. That was interesting, and controlled a 12-volt wiper motor with it. We used a common L298 motor driver. Sure. Okay. I guess you guys are seeing, you're not seeing me talking to you, you're just seeing the Dremel. You know what, I think I'm going to try hacksawing these screws. It'll take probably less time than the Dremel tool. So, take a quick break, and I'll be back. I'm going to go to the back and hacksaw these things. And I'm back. So, the weather here has actually been amazing. We've had the most warm December that I can remember. Of course, DJ will say, every December is warm. What are you talking about?
Check Facebook.
Yeah, check Facebook. Yeah, but Calgary does have some interesting winters with the Chinooks that come through here. Whoops. Yeah, how's the weather where you guys are at? Oh, Ontario is getting cold. Okay, I'll transfer the view for a second here. Alright. So we're gonna find, yeah, I was right, the hacksaw definitely made short work of that job. Shouldn't have done the drum in the first place. Okay, so I think these are 1032s. They might be a little bit larger. 1032, here we go. Yeah, I think they're a bit larger. 1224s maybe? Okay. I think that's right. We can use our little thread measuring tool here, just in case. See if it's 24 threads per inch or not. Tried 20, but wasn't matching up. 24. That is correct. Actually, it's not exactly 24. This might be metric. We're dealing with automotive parts, so could be the case. You sure about that?
Well, depends. Where's it from?
Princess Auto?
What vehicle's it for?
I don't know.
It's all, the automotive industry is the only industry where the fucking Imperial still exists.
You know, this is definitely metric. It's 1 millimeter, I think. I don't know. How do you count threads? And
Oh, it's a lot of peppermints over here.
there's a lot.
Holy.
So M8 by 1 looks like the right one. Yeah, that's the one.
Is it an 8?
M8. But
You have to get the screwdriver and put it in. I think that's the one, right?
that's the one.
Okay.
Thank you. Yeah, I always forget. When dealing with automotive in Canada, everything is metric. I don't know.
Oh, that's not true.
Most things. Most things are metric.
Ford is from North America.
Oh yeah, I never thought of it. Everything that I use on my Hondas are all metric. Yeah. My bad. Hadn't thought about that. Domestic vehicles are likely more imperial. Imports out of the metric. I hadn't noticed that.
What's that?
Every time I drink a drink, my voice goes down an octave.
I wonder why that is.
Yeah, I don't know either. Maybe I sound more manly when I drink alcohol. It's the Old Spice effect. Alright, there we go. And that's how you shorten screws. Machine screws. I'm sure there's better ways. But we made it happen. Okay, let's test them out in the motor over here. There we go. See how far it goes down. I tried to leave it so that it has a little bit left, because it's more than I anticipated. Maybe that one is a little shorter actually. Interesting. You know what, I think I just have to give it a little bit more oomph. Those will go down further. I think the thread might taper out at the bottom. Let's use the bigger screwdriver, the number 3. Now we got it down about a centimeter further. So you have to make sure that this guy here will clear the screw. Oh man, we are very close. I don't think it's going to go any further. What? What?
Cool, cool.
Oh, I got something working? Nice.
I need a USB 3 extension cable.
Oh, that one's a little longer than these ones. I think these ones are going to make it. Yeah, there we go. That's much better. No clear, no problem. So this, I notice this screw actually has a little bit left on the bottom here. Let us chop it off with the Dremel tool. Test this one as well. Well, I think we're gonna have to shorten this one as well. Son of a gun.
You son of a bitch. I'm in. Rick and Morty, it's you son of a bitch. I make fun of every English, those type of movies that are like, let's get the group back together. We're gonna do heist. Jeremy Bullion, you son of a bitch. I'm in.
That's funny. Actually, I think I'm just gonna hit them with the angle grinder at the back. It'll make it so much faster. And by angle grinder, I mean bench grinder. My bad. Okay, you guys can hang out with DJ for a little while.
No, don't look at that.
You know what? I'll make this one a little shorter too at the same time. Okay, see you in a bit. Hopefully DJ didn't tell you guys my deepest, darkest secrets while I was gone. These guys are pretty hot.
Pretty sexy.
Gotta be careful of them. Of course, we have to run them through the dye one more time. Make sure we're not cross-threading. There we go. I kind of mangled the threads a little bit at the top, so I'm going to run it all the way through. Oh. These guys are getting in the way. Oh, they're pretty good. Loosen these up. You know what? I've never used the back of one of these die tools before. Anybody know what that's used for usually? This part. Yeah, I've never seen anybody use it for. Could be used to grab onto a tap, I guess, but run that on back through to the other side. So what's everybody working on these days? I know RoboRad was fooling around with that Roomba. And by fooling around, I just mean he was working on the Roomba. And Nomad, you were, engine rebuilds. Nice. Nomad, you were working on, are you working on the move these days? Dialect? Oh, yeah, the Dialect. I forgot about that. 3D printed Dialect. That's awesome. Looks like really getting into the 3D printing stuff. It's awesome. It's pretty fun stuff, isn't it? And Pedro, any projects these days? Sorry, I know this is not too exciting watching me rethread these bolts.
I didn't know that gray spell was a A, not an E.
It could be both. It could be both.
Not in the internet.
But
Computers
what does Grammarly say?
I don't use Grammarly. I know how to type.
What?
I know how to type. I don't need to use Grammarly.
Come on.
I don't need to use
If you're
Grammarly.
asking what grade to use, then you definitely don't know how to type.
I think I've always typed in GRAY, but I've never gotten a warning about that.
Yeah, I always use that one too. Nothing new. All right. Well, which way do you guys spell gray? With an E or an A? Let me know in chat. I'm cross-threading this one, which is not doing it right. Okay, let me clean this out for a second. Yeah, I'm definitely cross-threading that. Be careful here. So. Little Raz says the next time we have a Christmas party, should have a Roomba with a bin on top of it that picks up all the beer cans. It's there for people. Throw their cans into. I think that's what he's saying. He just drives around and you throw your beer cans in it. And it goes by.
Good idea.
I don't know if many Christmas parties are going to be happening this year because of the COVID crisis. Okay, so we have our M8 screws prepped, ready to rock. Take care of that later. Do one final test. Make sure they're down far enough. Yep, that's plenty of room. Perfect. I'm just worried about this one over here. Yeah, that's good. We're golden. All right. So get those out of there. Remove this as well. And we'll have to make a hole pattern in our diamond plate that can accept this. So we'll have to drill 3 holes. And we'll kind of have to figure out how high we need to mount it on the diamond plate as well. So I think I will have to run to the back with it. I'll have to leave you with DJ again for a little while. He's busy at the moment. Look, it happened again. My voice got deeper.
Because every time you drink, you turn into Clint Eastwood.
Maybe I turn into a gremlin every time I drink. It's the water.
Oh yeah, look at this.
That thing's supposed to text.
It can't do lots of different things.
Okay, here we go. This is the diamond plate. I'm going to bring it back, cut it with jigsaw. So, yeah, we'll see you guys back here in a bit. Take a little break. pieces here. This is what we wanted to make. A plate like this, the 90-degree bend. I'll have to use a file to file the edge down. It's pretty sharp right now. All right. Put some of this stuff away so we have some room. Yeah, that waterfall, drinking water comment with the audio, that was pretty good. Oh man. Okay, get in there. There we go. This thing away. Okay, let's do some filing. Get these edges down here. Oops. Knock the mount off there, my bad. I'm not going to do too much filing, just enough to get the sharpness off of there.
It's red, it's not moving. It doesn't go up or down, just like this.
Nice.
Yeah. So it goes back exactly where it was, and it'll be back in the exact center where it started from.
Is it just using an accelerometer?
Check it out. You turn it.
It's not using the cameras, is it?
Yeah, it's using everything.
Oh, wow.
Yeah, it's using sun.
Crazy.
Yeah.
Sorry, I'm just checking out a secret prototype that DJ's working on.
The real sense.
It was the blah blah blah.
Here, put your camera on this.
The camera showing me filing stuff.
No, show you. Where's my...
There it is. Secret project.
See it on the screen?
Yep. You're getting a little demo here. Hopefully you're still watching. It's pretty neat.
Yeah. You can save paths and waypoints. That's it. Then I go watch Jeremy file.
Isn't this more exciting than DJ's secret project? Looking at a McDonald's up in the garbage with a file in this?
McDonald's got them in there? Why? That day?
From that day, yeah.
That day.
From that day we got dirty. We got McDonald's.
Song is a lot.
Alright, I'll switch it. Okay, almost there. Just getting off the last little bit here. We'll be able to measure everything up and see how it connects all together. Okay, I think that's good. Maybe a little more. I'm getting, what do you call that? File happy. Going crazy with the file. Okay. Okay, good. And by navigation, I'm guessing navigation. Yeah, there you go.
What did he say?
Robrad's like, secret project. What? And he's like, some new navigation, I bet. And he meant navigation.
I think so.
Okay. A little bit more. Gotta file a couple things down. Once you start filing, you can't stop.
This might be better than the IPS.
Oh, come on. Well, it is a legit product from Intel.
But I got like a really good idea of how this can work. Now the IPS can't do obstacle avoidance either, but with a simple distance sensor, as long as your robot can bounce around and figure out how to get to where it's going, it will track that direction. As long as it replays that same path, it can get back anywhere. You can specify multiple waypoints, and any obstacles away are relevant. It just needs to figure out how to get there. So if I say there's a waypoint in the picture,
Yeah.
the problem is the robot has to start in the exact same orientation and position every time.
It does, yes.
So you're going to put some tape on the ground and say, this is my motherfucker.
Can't you do a little calibration thing like IPS? Like start driving forward and be like, oh, okay, that's forward.
No, it's not about forward, it knows forward. What it does know is the starting position. Starting position is, so if I go right here and I hit clear, this is now the starting position. If I go over here and I clear, this is now the starting position. So wherever you start from, it doesn't know. If you start from over there, it doesn't have a GPS, right? It doesn't know. Yeah. That's okay, as long as you start in the robot on the right place.
So you want to have a space that you're always starting from, like on the floor or something.
Yeah. You just put some tape on the ground and say, this is where my robot started from.
Gotcha.
You turn it on. And then from that point, it will know, based upon the map you created, it will know how to get into any room.
Yeah, that works. All right, so
All right.
Matthew McConaughey,
Nice.
ourselves over here. Let's use our clamps.
Give him the clamps, boss.
Okay, we got our clamps. Let's bring our motor over here. Let's get our skateboard over here. Let's move our camera back a little bit. That'll make things easier. You guys aren't getting motion sick right now, my bad. Okay, so this is what we have to figure out. We're going to mount these clamps onto the plate here. I might have to drill this hole a little bigger. To fit through here. Give me 1 sec. Or we could thread it through. No, let's do it. Let's use a clamp. Clamps always make things easier. Definitely pretty tough. We got it.
You got it? You got it. You got it.
Oops. just a tiny bit too tight. We could move up a drill size, but I'm feeling like if we hit it with the file, it might make it work. Actually, I'm just going to ream it out with a drill. Put it on the number 2 setting. Clock it back in the clamp. Just do this. Oops. There we go. It's going on through. Okay, let's measure this out again. I didn't notice that until DJ pointed it out that I say alright a lot.
Alright, alright, alright.
Yeah. Alright.
Matthew McConaughey.
I guess. I like Rain of Fire and post-apocalyptic movies that, what's his name? So, we already know now that we're going to have to space this out further away. And see how high this has to be. So So I think we're going to have to drop this down. So the motor can be basically anywhere now, since we have to drop this down a little further. Just out about there. And drop down to, yeah, about there. So we're going to have to make some brackets that hook up to the bottom here and here to space the board out a little further out so that this foot can hit it and drag on it like so. So we can likely position the motor like this, where it's kind of flatly sitting on the bottom there. I think I'll have to make myself like a little, I'll take a sheet, poke through here, let's see, okay, I'll take a little stick tab. And we'll figure out where these holes are at. Make sure it doesn't twist or move. There we go. And there's our hole pattern. So we'll have to put that on this side, likely. figure out where the center pin is going to go, and then we can mount this guy directly to this plate. I'm going to position it probably a little bit off center because we want to put some screws down here and here for those clamps that are on the skateboard. Okay, let's do that. In my pocket. So the premise of this project is to test grip tape, and so this foot is going to slide along the grip tape with this TPU material, and it's just going to keep on going and wearing down grip tape with it. Likely we'll go through a few pads before it's worn, but we'll replace them as needed. But it's going to check to see how long the grip tape stays grippy for, and we can measure that with the base of the H-bridge, the ground of the H-bridge. This guy here, we'll tap off of there and connect that up to an ADC pin, measure the current. The current pops up as a tiny little voltage, basically, is what happens. It's trying to remember the name of it. It's just an offset voltage, kind of comes up off the ground, and then you can tell that a current is being drawn.
DJ's voltage.
DJ's voltage, that's what we can call it. That's a good name.
It's what happens in the motor is the energy isn't consumed by the magnetic field of the spin, and it passes through the coil and ends up shorting out into the ground line. So the more voltage you see residual in the ground line is because it's not being converted into magnetic energy, but the motor's holding it back.
Did you guys hear any of that? I'm guessing no. Sorry, DJ. My microphone doesn't pick up that far.
It's okay. It's gonna drink a beer, so my voice is low.
It happens to DJ too.
Harder, guys.
Whenever we drink, we turn into pirates. Actually, I gotta grab another cider. It's time for another cider.
I would like one. All right, we'll get one. Get one. You wanna try this a little bit? No. Intel made something I actually like.
Well, we liked the Jewel until they discontinued it.
Yeah, well, that's probably why I like it.
Watch out, DJ. You'll get attached to the Intel RealSense and then they'll discontinue it on you.
That's exactly what TTP is saying right now.
Is he?
Probably.
That would be funny. That's crazy.
What?
That is so weird. So I think I used this exact part to do some measurements before, and it looks like the exact place where I circled has a little cross that I marked on this thing a long time ago.
That's funny.
It's like exactly in the middle.
Huh. And you second guess yourself and never went through with whatever it was.
Yes. Okay, so I'm going to make sure this is lined up properly. Alright, we'll drill those out. Kind of wish that I had this on the other side. It'd be way easier to drill on a flat surface than drill through some of these diamond pieces. You know what, I'll do a pilot hole on the other side and then drill it out after. How low can my voice go if I keep on drinking? I'll have just like all you guys will be able to hear is.
It's like a foghorn.
Yep. There's some of that dubstep I was telling you guys about. Did you turn it down while I was gone? Let's switch songs here. Actually, let's go back and play. Let's shuffle the playlist. Alright, here we go. Alright, let's do some drilling. I could probably move the microphone so you guys won't have to hear that as much. Drill those holes bigger now, and then we'll fit the center shaft through there first, and then we can measure and see. Well, we can eyeball and see if these holes line up properly. Just trying to figure out which drill bit to use here. We'll go bigger. Go to the big size. Yep, good. Don't want to lose that guy. Tight, I guess. All right, let's test fit that. Could be a little bit bigger. I don't know if I have a big enough drill bit. I would probably have to ream that out. This is the biggest we got. Yeah. Using solder guard to melt plastic is definitely not ideal. I hope that you find your drill. Okay, we're in business. Now to see if these holes line up. Let's use a little bit of light. It looks alright. We can always offset the holes a tiny bit if we need to with the drill. Alright, so we'll get the drill bit to match the size of these screws. Alright, the moment of truth. Let's see if the holes line up. Not perfect. Close, but not perfect. So the bottom one looks to be pretty good. I don't know if you can see that from there. But these two are off. So we'll just use the, well actually we'll use the Dremel to ream these out a little bit. Faster. Alright, off to the Dremel we go. Alright, we're back at it again. Check this out.
What camera is facing you right now? Oh, no.
Back over there. Alright, thanks a lot for joining us, Rubber Rad. Have a great night. We'll catch you next time. Alright, so I think I actually still have to do a tiny bit more. Doesn't look like we're going to fit perfectly there. But yeah, after I get done this, I think that'll be it for me too. Take a break until next week. I might work on this some in my spare time. We'll see. Oh, that seems to be fitting okay, actually. Now we'll have to also test to see if our little bracket will clear it. Oh yes, here it is. Alright, we got it on there. So, on this side you can see the diamond plate is actually in the way a little bit, right up here. So I could use the file that down, get a closer fit, also down here as well. Because I think that this bracket won't go on there perfectly unless this output shaft can stick out a little further. Yeah, we'll have to do that. But it looks like everything is clearing, so that's perfect. Great news. One thing that I had forgot about that I'll have to do as well is to check and see if this will rub or not once it's on there. I think it's going to. So there's one of two options. We cut the heel off of the shoe, or we find a longer bolt for this, and I'm hoping I can find a longer bolt. Okay, well, I'm guessing you're probably getting a little bored of me just fiddling around with mechanical stuff. What's going on in the chat?
It was answering. What was it? It has rubbiness.
Oh, wow. Rub-a-dub-dub. Cheers.
Cheers.
Cheers to live hack number 50.
It's Jeremy's 25-minute goodbye.
All right, start the clock. Oh, went down the wrong tube. All right, let's put this just on me here. I'm gonna have a tearful goodbye. Thank you for everyone who's lasted this long. Thanks to GJ for joining me on this this wonderful journey. And hopefully we have 50 more of these.
Stay classy, beautiful people.
Yeah, it's I guess I have. I haven't said it all, or have I? Have I said all the goodbyes? No.
Now, there's that thing you used to say.
Stay radical, everyone. Yeah, I don't know. What was my classic goodbye?
You used to like 3 or 4 of them to try them on.
Yeah, I was trying a few every now and again.
No, you do all 3 of them at the same time.
At the same time?
Yeah, you did. Stay classy, San Diego.
Yeah, stay classy, San Diego is a good one. I don't know if I've said it, but
San Diego, real vagina.
all right. With that, we're gonna end the stream. Thanks for joining.